So welcome after lunch. My name is Paweł Śniecikowski. And I'm from Samsung R&D. And I would like to tell you today about mobile security challenges and solutions of Samsung in this area. So let me start with a few numbers. I think I don't need to convince anyone that our world is getting mobile, more and more mobile. But if you look on the numbers, you will see even more. So from the whole worldwide population, which is almost 7.5 billion people, today we have almost 5 billion unique mobile users. So it's around 66% of the whole population. So it's a lot. Most of the people are using mobile devices today. If you compare it, mobile devices, the usage of mobile devices versus other devices, so it's around 55%. If you look on the internet connections, so 55% of internet connections go from mobile devices today. So we are using more and more mobile devices, and we are using these mobile devices not only for calling, making calls, but for many, many things, especially which requires internet connection. If you look on enterprise market, also mobile devices is becoming used for business. So today, if you look on the numbers, in 2016, more than 500 million devices have been sold to enterprises, for business purposes. And people are using this to access company emails versus company services. So these mobile devices are becoming more and more used for our daily work. And what about the security? Everyone knows here that security is important, but when we are talking about mobile devices, it's still relatively new area. How to ensure the security of the mobile device? If you look on some reports, almost every company, 90% of companies they believe they are not well prepared for cyber attacks on mobile devices. And mobile devices are every year much more became target of the attacks. So how to make mobile device secure? First of all, we need to have a look on the device, how it's working. So as I said at the beginning, it's not anymore single-purpose device. So like 8 years ago, the situation was very simple. We used mobile devices to make calls and maybe send SMSs, maybe some few simple things like games or whatever. But now we use mobile device. We expect from mobile device that will be actually it is the computer, but we expect that we'll make many things on that. So we check emails, we access company resources, we go to internet. We play movies, we take pictures and record movies, and we use GPS. We would like to this device to make plenty of things. So it has to be complicated, and it has to be. So if we are talking about protection of such a device, we have to look on different levels, on different components of this device. As you very well know, every system is so secure as the single element of such a system. So I put here from some report in 2016, some top 10 most critical risks in mobile devices. I'm not going to cover all of this in details, but just would like to give you the picture how complicated is this area to protect the phone, the mobile device. So first of all, platform usage. Platforms today must have many APIs. So as we would like this device to make many things, the operating system has to provide many functionality. So, and we provide, of course, as Google provides, we as Samsung provides many guides, but we see that many times these guides are not followed, and there are some problems related with this improper platform usage. Then we have insecure data storage. Very important thing. Still, in mobile devices, the data are kept in secure way, so it's unencrypted. So if you lose such a device, it's very easy to get access and to take out this data from the mobile device. Secure communication. There was lots of information about secure communication in the previous presentations, so like SSL, VPN, these kind of things. authentication, cryptography, authorization, code quality, code tampering, reverse engineering, and some extra functionality. So this is probably not the most critical. This can change, of course. Maybe it depends on the usage, how we use the device, for what purpose it could be a little bit different. One more thing. Last year there was a report in Poland about security of mobile banking applications. So journalists from one IT newspaper took 12 or 14 mobile banking applications from the most popular Polish banks, and they made an investigation of how secure how the applications are working, how secure the applications are. And they find that it was 2 or 3 applications that during development, the developers leave some extra features which were very useful for testing, but when it goes live, it actually provides lots of information which could be used again to attack this application. So, for example, there were logs with PIN numbers. One was with PIN number, another one was with some user details, user private details. So, as you can see, there are plenty of things which we have to think about when we would like to make the mobile device a secure device. Typical attacks. So there are plenty of attacks. I'm not sure if these are the most typical, but of course malicious software is one of those. So how to protect against that? There are many ways to protect, but of course we have to in the enterprise infrastructure, we should implement mobile device management, and we should distribute applications from this mobile device management solution. But data encryption to prevent against stolen device or lost device. Of course, training, of course, security patches, because every system has some issues from time to time. So fast reaction and deployment of security patches is very important. Man-in-the-middle attacks, so VPN, SSL, this kind of protection. So there are many ways to attack the device, and so we have to think about complex system of the protection of the device. Some examples. So from run scanning, you can get out the email, text, or browser history, or even the pictures. So these are real case attacks. So I think that nowadays mobile security is becoming the priority in the companies. In many companies, this is getting to the central place for protection. What are the other challenges? So we said about security, but very important thing, privacy. So it's very relatively easy to make a big protection, to install some software, to monitor the device, monitor the activity of the user on the device. But privacy is also a very important thing. When we are talking about laptop, I can close my laptop, leave the office or leave the house, and that's it, right? With mobile device, I usually take the mobile device with me, I make some calls, I'm checking something, maybe I enable GPS, so I do lots of activity from my mobile device after my working hours. So I don't want, and probably no one wants, but my IT administrator will know where I'm going, what I'm doing after my work, or these kind of things. So it's very important to maintain the privacy of the user. To do that, we have to have efficient way to manage the devices, and also another challenge to maintain the user productivity. So we don't want this device to be locked to some two or three functions, and the user cannot do anything else. Let's go to the next slide. Some more. So Samsung provides some solutions for these challenges which I just presented. So security, for privacy, manageability, and productivity. And I would like to tell you a few words about these solutions, how they are designed and how can be used by our partners, by our customers. So first of all, Samsung Locks technology. It's in the market for a few years already, so probably you heard about that, or if you have Samsung device, you should have Samsung Locks platform already in your device. So every device every 2017 mobile device from Samsung has Samsung Knox platform built in. How we design the security in this device? So, as mentioned, the system is as secure as the single element of the system. So we decided to start to build the security from the bottom, so from the chip. Samsung calls it hardware root of trust. So basically we use a chip it's based on ARM trust zone technology. So the chip is divided into two spaces. There is a so-called secure world and normal world. So every normal functionality, every operating system operation, applications are processed in the normal world. And trust and the secure world is used for this Knox platform operations plus some very sensitive security operations like cryptographic operations or storage of cryptographic keys or these kind of things. So this is starting the chip. So it's hardware isolated. These two spaces are hardware isolated in the chip. So what happens when we press the power button? So when we press the power button, there is a so-called bootloading process starting. So bootloaders are loading drivers and some next levels of the operating system onto the operating system. So it's called secure boot. Secure boot, during secure booting, we are checking the signature over these bootloaders. So during production, as a Samsung manufacturing also the chip, Samsung is programming the secure boot key, public key in the chip, and during this secure booting, we are verifying the signature. So if the signature is verified, it means that the bootloader comes from Samsung. If it's not, it means that someone replaced it for a non-Samsung bootloader, not Samsung firmware. Trusted boot, we are checking the version of the bootloader, so it cannot be reversed back. So if there is some security issue and Samsung released a new version with some security patches, maybe some attacker would like to go back to the previous version to expand this functionality. So it's also in hardware some fuses which are blocking to go back to the previous version. We have some special layer which is sitting below the operating system, so-called trust zone-based integrity measurement architecture. Is TIMA, and TIMA is responsible for monitoring the operating system, the key elements of the operating system, do some periodic measurements and some real-time measurements. We have adopted security enhancement from Linux for Android, and this is responsible for maintaining the access control between applications, so kind of firewall between applications. So even if you get a root privileges, you will not be able to access to another application data. And on top of that, we have Knox solutions. So this is the platform. On top of this platform, we provide some solutions, like Knox container. And I would like to tell you a little bit about these solutions now. One more thing, Knox platform got some awards. It's certified by some international certification, common criteria, which is mostly used for government applications, plus FIPS. FIPS is used for cryptographic operations, so it also has some FIPS certification, and it has been approved, certified in more than 2,000 countries already by the governments or governmental institutions in those countries. So we put a lot of effort to make Samsung Android much more secure than the standard Android. Of course, Google now is also doing their job, so they are investing lots of money and lots of work to make Android more and more secure. But we started a few years ago, and we are, let's say, in the top of this race. So, on top of this Knox platform, as said before, we provide some solutions. We have some security and management tools, so we have some deployment and customization. And for security, I would like to focus on Knox Workspace, because it's important for answers the security challenge. So what is Knox Workspace? Probably you heard about containers. So we create some special area isolated in the smartphone, in the mobile device. So we divide the smartphone for personal space and for workspace. In personal space, the user can use whatever he wants to, applications, Facebook, Instagram, whatever he wants to. in the workspace is created by the IT administrator through MDM solution, so mobile device management solution. So it's created and it's managed, controlled by the IT administrator. So IT administrator is responsible for pushing policies, pushing applications, setting VPNs, setting firewalls, all the configuration. So, and the workspace is encrypted. So all the applications and data sitting in the workspace are encrypted. And this encryption comes from keys which are sitting in hardware. So during production, Samsung generate some keys, so-called device unique hardware key. And from these keys, there are derived another keys, and these keys are used for encryption of this workspace, of this data and these applications that are sitting in the workspace. So what is important also here, that in this design, we are thinking also about privacy. So as you can see here, we can at the same time control the security, so ensure the security, because the data applications are encrypted, so they are secure, and there is authentication. So to get access to this workspace, you have to authenticate. It could be done via password. You can integrate it with Active Directory system infrastructure in your company. You can do two-factor authentication with biometrics. But so you have to authenticate to the access to it. And so this is the workspace, the work area. So we maintain the security, and at the same time we have the personal space, which is not controlled by the IT administrator. So we can keep user privacy. User doesn't have to worry that my IT administrator is controlling my data or my traffic or is checking my location or whatever. One very important thing, there is some hardware fuse. So during the booting or during the working of the device, Samsung Knox platform discovers that, for example, someone exchanged the software, exchanged the firmware, or rooted the device, or made another security breach. It is discovered the hardware fuse is switched. It's only one way, one time switching, so it cannot be reversed back. In such a case, the whole workspace is blocked, the Knox platform is blocked, so there is no access to cryptographic keys. So you can have if you have no access to cryptographic keys, you cannot decrypt the data. So it's blocked, and this is permanently blocked. Another thing I mentioned about some malicious software and some security issues. So every system, whatever it is, Samsung, Microsoft, Apple, from time to time has some security issues, or there's some bug or something like that. And this is quite normal, I would say. There is no absolute security, so there is no system which is forever secure and like this. So the important thing here is that the Samsung or Apple or whatever the producer is has to react fast for such a security issue. So provide so-called security patch or firmware upgrade. So we call it's called FOTA, firmware over the air. So if you have Samsung and another device, from time to time you get security update or firmware update, so you install it or not, depends on you. So we introduced enterprise FOTA. So what does it? What the enterprise FOTA is doing. So first of all, we are giving the IT administrator the possibility to selectively install the firmware. So the IT admin can first of all test the new firmware, check if the application is working on this firmware or maybe it needs some improvement or changes in the application, and he can choose which version will be deployed to the devices. So in previous time, you have just one option. You can install the latest version or don't install it. You cannot choose which version will be installed. The second thing is time controls. The IT admin can control when it will be installed. In the night, in the weekend, whatever is good for you. And maybe the most important thing, the first update. So now, as a user, you can postpone it, you can cancel it, you can disable updates. With this solution, a user cannot do anything like that with this. So he has with this solution, he has some time, like 6 hours or 8 hours, it's decided by the administrator, and after that time, it will be forced. So it will be installed without user consent. Yeah, so it was about Nox. A few words about the latest solution from Samsung, which was introduced this year. Actually, in Europe, it's just starting now. In September, the first customers will use it in Europe in September. We have some customers in the US, some customers in the Korea already. So Samsung Pass. This is the solution for online authentication, secure online authentication. Very important thing, there is a PSD directive, so banking directive, the version 2, which is coming, I think, into force next year, which introducing so-called strong authentication. So, if you want to access your banking application, do some operations, login and password will not be accepted anymore. So you have to implement, banks have to implement strong authentication, so based on two-factor authentication. And this is this solution answered this requirement from PSD2, and it can be used not only for banking, but also another services. Yeah, password, passwords are, let's say, good for some purposes, but when we are talking about more secure authentication, it's not as good anymore. I don't want to bother you with these password stories, but the passwords, the most popular passwords probably here, and there are passwords like first name and date of birth or plenty of this. It's not very difficult to grow such a password. But it's simple, right? So we, during design of Samsung Pass, were thinking how to make a solution which is first of all secure, because it's of course priority, but it has to be simple. So users basically will not use anything which is complicated, will bypass it or skip it or don't use it at all. So it has to be simple, and it has to be integrated, easy to integrate with existing infrastructure. So how Samsung Pass will be working? It's working already. So we based Samsung Pass on biometric. So instead of login and password, the user will be asked to scan his fingerprint or iris, if you are talking about some S8 devices or another devices. And we will introduce next biometric features in the future. I will tell you a few words later about the plans of it. So, very simple. Instead of, when you have, for example, banking application, instead of putting login password, we are asked for our iris or fingerprint. Of course, we have to register it first. So first we need to do some registration. It's quite a simple process. And then we just ask for this. Also, it could be used for PC. So on the PC, when we log into the computer, instead of getting SMS, typing some text from SMS, we'll be asked, the message with fingerprint or iris scan will be pushed to our device and will be authenticated on our device, and the message will push back to the server and we'll get access to the bank. Of course, the process can be done. We provide technology, so we are not telling our customers how to implement the process. So it could be also different, like you can log in with your login password, like you do right now, probably, and then for money transfer, for more sensitive operation, you can use this Samsung password, like iris scanning, for example. What is the security of Samsung Pass? So first of all, this is the device. In the device, we use this trust zone technology and Samsung Knox protection. And we keep all biometric information in the trust zone. So it's in this secure area of the chip, and it's encrypted, and these templates, biometric templates, never leave the device. So it's not sent anywhere, so only sits in the device. In the whole process, I will send on the next I will show you the next picture how the process looks like. We have the Samsung Pass server. It's based on FIDO technology. FIDO is a Fast Identity Online alliance. This is the alliance of one of the biggest IT security companies which decided to make open standard for online authentication. So there is such a standard, and we are using this FIDO standard. Basically, in FIDO, the key rule is that first of all, it's based on biometric features. Secondly, it's based on public infrastructure. And the third thing is that no secrets are sent between servers or devices. So there is no secret data sent somewhere. So this is the basis for security. So the secure device, the Samsung locks and the trust zone and secure storage of biometric templates in the device, and the FIDO server who is in the process. So let's have a look how the process looks like. Oh, you have the partner application, it could be banking application. So this has to integrate Samsung Pass SDK, and from this SDK there are APIs which are used to connect to Samsung Pass framework, and this framework is responsible for this biometric or on-device biometric authentication. So when you try to log in, you push the button login with Samsung Pass, then we are asked for scan our iris or fingerprint. We do it. If it's successful, there is a token generated, and the token goes to Samsung Pass server. Samsung Pass server verifies the token. If the token came from the registered Samsung device, so it's signed by the private key of the device. It verifies if the token came from registered application. So partner has to register the application, Samsung, and there is some key exchange protocol, and then Samsung Pass is verifying the token signature which comes from this registered application. And then if it's okay, he signs the token with his own private key and sends back the token to the application, and the application sends it to the server, and server at the end can make token validation. So can actually, via some REST API, ask Samsung Pass server, hey, this is your token signed by you. If it's okay, he gives access to the application. So this is a Samsung Pass infrastructure architecture, and as I said, today is based on fingerprint and iris. We will introduce also face recognition, and another thing which I would like to, which was just introduced now at IFA show two weeks ago. So on top of this iris, fingerprint, and face, we'll add also handwritten signature. So there are two devices of Samsung. It's a Galaxy Note 8 and Tab S3, which supports this S Pen technology. So with this S Pen technology, you don't only collect the picture of your signature, so the view of your signature, but you can also collect pressure, how strong you push the screen, angles, rotation, altitude, azimuth, and you can measure, of course, speed, acceleration, these kind of things. So you can actually measure biometric data of your signature, not only the visual, the picture of your signature, but the biometric data. So how can we use it? So there are plenty of ways. We are already in discussion with some partners. But for example, in this flow, your partner can send you an agreement. You have to authenticate yourself in Samsung Pass, so you ask to scan your fingerprint or iris. If you are authenticated, then you get the agreement. If it's okay, you can sign it. So you make the signature, the biometric data together with this visual, the picture of your signature is processed, and there is some encryption in the way, and it's added to the contract, and then the contract can be signed to the user, to your partner. We have already some implementations ongoing, and we'll see how this technology will be used in the future.
Can you elaborate on the signing process? Is it actually trusting the device or trusting your fingerprint? Okay, and the solution service online? Which one?
I'm sure I get your question.
So you're using your fingerprint to authorize doing something in your phone. So that's from that on online there's a server that creates the public key or whatever private key there and certificates for you, and these are stored in your device there. Yes.
It's generated in the device. It's not created in the server. The private, we are not talking here about the biometric signature, but about the keys, the key part. So the keys are generated in the device, and the device sending public key to the server. So the private key is generated in the device and never leaves the device. So it's absolutely not possible to without this private key. And server also generates the key part, and it's a public key exchange.
Okay. So the process is only on device, on your mobile phone.
Yeah.
So if I'm how do you reset the phone, or what's the backup solution?
Backup in case of what?
I just cut my finger. It doesn't work anymore. What's the backup process?
Well,
Get a new one.
yeah, you can delete your templates. So you can delete your account. When you delete your account, all the biometric features are deleted. You can re-register. So you can register. There is some process how to exchange.
Yes, but the same process is still done in phone. So how can online service provider trust phone? Because okay, I'm just my phone got stolen. So another one goes, okay, reset the data, put our own data there. Okay, I'm good because phone is there, data is there. Good. So what's the trust mechanism? How do you trust the provided keys?
With Samsung Pass, to register in Samsung Pass, you have to register in Samsung account. And if you log in with Samsung account, you can block this Samsung Pass solution in your device. So you can remotely block it, for example.
So in order to use that, you have to have a Samsung account.
Yes.
So
To register in Samsung Pass, you have to make your you need to have your Samsung account. And with
you have
Samsung
to
account,
authorize your keys there. Yes.
yes, it's it's some binding process when these keys are registered. So you don't see it actually, but there is some key exchange and registration process. So if you lose your device, you can log into your Samsung account and you can send.
So what's the verification process that the device actually has my biometric data? What's the verification?
Verification is just you create the account in Samsung Pass, so with creation of Samsung account.
So how do you verify it's me? It's not me.
We don't verify it's you. So now it's the technology which you need to make the identity verification. That's another story. So for example, in Samsung account, you can create that you are John Smith, right? We don't verify that. So for this verification, we have some plans and we are working with some identity provider partners, but there will be some verification. So we connect our service to some identity providers, there are some, we are working on some partners not in Europe, and they will verify that John Smith is really John Smith. Right now, don't do that. So you can go to a bank and you can connect this service with some banking verification, and then you can verify the identity. So right now, it's identity verification is not yet here.
Another question is about the Knox. You need the Knox in the phone in order to work that. So basically, it means it's usable only on Knox environment, not in personal environment. Yes.
You must have the Knox platform, but you don't need to create the Knox workspace. So Nox workspace is something which is created by the MDM solution and it should be used to store application data. And Samsung Fast is using the Nox protection, but it's not what we call the Nox container. Project. Okay, the projector is off. Because my presentation was okay. Yeah, so we don't need to create container. So we are using this Nox encryption. So the templates, biometric templates and data of Samsung Fast which are sitting in the device is encrypted by the keys which are Nox, right? But it's Samsung Fast framework. So user, we don't need to create any container to store it. So it's unvisible for user.
Some standard container in it's like container.
Yeah, so Nox is needed. Yeah, it's almost clear. The last interesting thing, maybe not very much related to security, but to productivity, how to use the future, how might people use the future our mobile devices. So we introduced the Samsung Dex, this is so-called Samsung Dex, and it's kind of a docking station. So you put the mobile device, you can test it in the look our book. You can put the mobile phone to the Samsung Dex, and then you work on it as a connected into the we call it keyboard, mouse, and the monitor or TV screen. It has to be full HD, and you can work on it as you are working on your PC or laptop. It's of course Android system, so this is so we are still using Android system. But if you use Microsoft Windows or Linux, you can use virtual desktop solutions. You can use also virtual Microsoft Windows or other things. It's multitasking for if you don't need any very sophisticated software which is not ready for Android, you just use standard Office applications perfectly can be used in such a device in Samsung Dex. So we'll see maybe in the future of working with mobile devices. Thank you very much. If you have any questions, please ask what I will do after.